so you guys saw the video, the power control valves. Let me take a little bit of time and give a little more explanation on two-stroke engines, so maybe it all makes sense. We're familiar with a four-stroke engine. Most people, let me just run through that. It's called four-stroke because the piston, we're talking about it moving a total of 4 times when you go from the rest position, up 1, down 2, up 3, down 4. Okay, so we have a four-stroke engine. Now, what that means though is, how do I make this thing operate? Well, I've got to have an intake stroke. It starts down, valve at the top opens. It allows a fuel-air mixture to come into the cylinder. When the piston reaches the bottom, it starts to go back up. The valve closes. That's a compression. This is a four-stroke engine we're talking about. So up comes the compression. Gets up to the top, spark plug sets off. We now have combustion, pushing the piston down. That's the power stroke. Down goes the piston. Piston gets to the bottom. That's the end of the power stroke. Starts back up. It's called the exhaust stroke because the exhaust valve now opens. Piston comes up pushing all the exhaust out. That valve closes at the top. Piston starts back down. Intake valve opens. We're back into. So it's a four-stroke engine. That's what it's talking about. There are 4 events taking place. Intake, power, and I get it right now. Compression, power, and exhaust. Okay, I got it. Now, in a two-stroke engine, we still have to have compression. We still have to have a power stroke, but we also have to have an intake and an exhaust. But we're only going to do it in 2 strokes, not in 4 movements of the piston. So how do we do it? We have a cylinder, and we put a slot and a slot on the sides. This is the intake, this is the exhaust. When that piston comes down and it reaches the slot, comes past it, on this side we start sucking in fresh air. Here comes the fresh air. We go down far enough to suck enough fresh air in that it scavenges or cleans the cylinder by pushing. There's more air comes in than the cylinder will hold, but it's enough, just enough to push all this exhaust out, and up comes the piston, comes past the 2, compression, ignition, bang, down it goes again. So, when you have two-stroke engines, if you think about it for a minute, I have twice the power strokes in the same RPM. Understand that? In a four-stroke engine over here, it's making literally 2 RPMs before 2 revolutions, complete revolutions, and in that it's got 1 power stroke. But in the two-stroke engine over here, it makes 1 revolution on the crankshaft, and it's coming back up to hit another power stroke coming down. Which is why we always talk about the incredible power of small two-stroke engines. That's why they really exist. Four-stroke engine is a little easier to manage than a two-stroke. Two-stroke is much simpler than a four-stroke, but you get into trouble with timing and your air volume in and out with 2 strokes, and you have to be very good at how you design it. So if we could make a 4-stroke as powerful as a small 2-stroke, but we can make 2-stroke engines that you can carry in your hand that can develop 30 horsepower. So there's no way you can do that with a 4-stroke. Now, in the best comparison of these, if you go out to the marine business, right, and you see these wonderful new 4-stroke outboards, and for the same horsepower, a 4-stroke outboard to a 2-stroke outboard, it's about 500 pounds more engine sitting on the back of the boat to get the same horsepower as the 2-stroke. And when you go, let's say you're a ski person, you've got a 4-stroke on the back of your ski boat, and you jam the throttle forward, and the skier goes, "Come on, pull me up," because the engine's going ramping up. Big 2-stroke engine. You jam the throttle forward, and it goes, it's up, it's going, and it's just jerking you out of the water. So the 2-stroke engine's a marvelous machine, but where they really have trouble is, like I said, you can see how critical it is to get the air in and the exhaust out. And the only thing you can do with it is this air comes rushing in, and the volume that comes in has to displace everything in the cylinder and push this out. So, in the exhaust port of that engine, if you're using typical petroleum two-cycle engine oil, the exhaust port can go from this big around to that big around in a matter of 25 hours of operation. Because the two-stroke engine oil that's made with petroleum two-stroke oils are loaded with zinc and phosphorus to protect the engine. Now the zinc plates out on the exhaust, it's attracted to the metal, and guess what's attracted to the zinc? Carbon. And since you have to mix these things so heavily, these two-stroke oils with petroleum, the unburnt oil is the carbon. So what I've done is I've put excess carrier oil in to put a whole bunch of zinc and phosphorus in to try to protect what they call anti-scuffing, actually anti-wear. And so what happens is I set up the perfect condition to plate zinc, plate carbon, and just watch that exhaust port shrinking down. Well, now what's happening with my ability to get the air through the machine? Can't do it. So all of a sudden I see my power going down. I'm going, what's wrong with this thing? So I take my real fine outboard engine, I go into boat repair place. The guy goes, yeah, we're going to have to decarbon the engine. That's the term they use. So they use something like our power foam with some really aggressive cleaner, and they spray this stuff into the intake of the engine while it's running, so that they get this, the exhaust ports just coated, soaked with this chemical. Then they shut the engine off, let it soak for a little while, and start it back up, and start blowing literally chunks of carbon out the exhaust. And that's their way they decarbon a two-cycle outboard motor. By the way, for AMSOIL guys, power foam is as good a decarboning agent as any of the expensive agents in the market. So if you go into a marine place and nothing else, you should just say, hey, here's a sample bottle of, can of power foam. Try this in your decarboning operation, see how you like it. It's a lot less expensive than some of the other stuff they buy with the name brands on them, and it's an excellent product. My boat place that I do the radio show with, that's all they use. They use nothing but our power foam. They wouldn't use anything else. It works like a champ, and it's not nearly as expensive as some of the other decarboning agents. So, how do you avoid this heavy carbon buildup in the exhaust? That's the question. How do you run a clean two-stroke engine? And the answer to that is you run a high-performance synthetic engine oil that's classified as a low or no ash oil. Now let me explain that, because that's not what the heck is low ash or no ash. If I take oil and I stick it in a burner and I burn it, I just burn it away. The residue that's left is called ash. And guess what won't burn? Zinc and phosphorus. So when they, in the industry, when they talk about a high ash oil, they're talking about that's loaded up with zinc and phosphorus that won't burn, okay? So this anti-wear stuff ends up being left in the thing, so we call that a high ash. A low ash or no ash oil means you didn't use any of that. You used a different kind of anti-wear additive other than zinc, okay? And so it has no ash. You burn it and there's nothing. If you burn AMSOIL two-stroke oil, there's nothing, it's low ash. Well, let me just clarify that. HPI is real low ash, and so is 100-to-1 outboard, real low ash, virtually zero. Now, the interceptor oil they're talking about using here, it may have a little bit of other additives in it because it's got a different heat range to run in. But oil companies that don't use zinc and phosphorus can use a variety of things. AMSOIL uses, we'll just say it's a high quality polymer, okay? And those polymers act terrific, but they'll burn in the heat of combustion and they're gone. So there's nothing to plate out on the exhaust. You can run a high quality AMSOIL two-stroke oil in any piece of two-stroke equipment. If you run it by the directions on the bottle, you don't try to get smarter than the company, what you'll find is it will run for ages with absolute clean cylinder, clean exhaust ports. My boat repair place took apart 150 horsepower engine, not important of the make, but this is an engine that has been running AMSOIL about 5 years of continuous, just each year they do the maintenance on it. It's a two-stroke engine. They've not decarboned this thing once. Well, they had a problem with it. They took it apart, and it's as clean as a whistle. And this thing has been run lots. This is a fisherman's 150 horsepower. So what you end up with understanding is that in two-stroke equipment, it's a miracle. I'll say that openly. It's a miracle that we ever lasted as long with petroleum-based two-stroke engine oils as we did. Because what we're doing, we're fighting against yourself. Remember, if you've got in your car, like we were talking before about the smell of fuel, well, what's one of the things that condemns motor oil in your car? When it has a concentration of fuel that's more than 3 or 4%, usually you have to dump the oil because it's got too much gas in it. Well, here I take my oil and I dump it in gasoline and tell it to go lubricate the engine. Where over here I tell it if you've got even 3 or 4% gasoline, I condemn it. So two-stroke lubricating regime is probably the most difficult lubricating regime in internal combustion application. And that's because you're already telling it, I'm going to mix this oil product in this gasoline. And so I can't depend upon it having any kind of thick viscosity because I've just thinned it with a whole bunch of gasoline, 100 to 1 in some cases. So what I really depend upon are those additives. Additives in two-stroke oil are absolutely paramount to preventing any kind of scuffing or wear. So how does that work out? Well, when you look at it and you use AMSOIL, or there's a couple other synthetics, I'll just stick with AMSOIL because all of the AMSOIL two-stroke oils have a base stock of ester. So the synthetic base stock for those oils is ester, not PAO, not group 3 hydrocrack, but ester, which is the most expensive. It's a group 5, they're called synthetic. Expensive base stock. There's a reason for that. The ester acts like a lubricant itself. So it actually has a lubricating quality that's not particularly diminished by mixing it with gasoline. So it starts off being able to lubricate. Then you put an expensive anti-wear package in it, which makes it now far superior to any of the petroleum oils. There's just no question. And if you look at what's happening now, Evinrude, they have the Evinrude E-Tech. The EPA rates the Evinrude E-Tech as a pollution-free engine. It passes the California Air Resources Board's requirements out through 2020 only if you use approved synthetic engine oil. If you use a petroleum two-stroke, you have to reset the computer and it loses all of its pollution ratings. It just pollutes like the devil with two-stroke. The reason is, in that engine, at idle, they're running 400 or 500 to 1. That's all the oil they're putting in with a high-performance synthetic that meets their requirement. It's about 400 or 500 to 1. So it's burning like a just perfect watch. It's just a perfect burner. And then as it increases power, the computer meters that oil very carefully. Now, there's an important thing to know about that though, and let me say this while I'm thinking about it. You have to be careful if you sell oil. I'll say this. When people buy oil for these new engines that are direct injected two-stroke engines, okay, because the oil does not mix with the gas. The gas is injected with an injector right into the cylinder with the timing the computer tells it when to inject it. They have a low pressure model, about 75 pounds of pressure. They have a high pressure model, 750 pounds of pressure, pushing that fuel into the cylinder, okay? But the oil's got to get there. So what the oil does, the oil is basically sprayed into the air intake coming into the engine, and you got a real problem. If you use some of these cheap two-stroke petroleums, they're too, what's the word I want to use? Too viscous, too globuled to actually mix in the airstream and get up into the engine, so they don't do it. So if you use, you have to be rated for those engines. That's my point. And it turns out that most of the oils really rated for those direct injected engines now are at least a semi-synthetic. And it's because they found they can't get the oil to work well enough in a, call it a vapor bomb, if you will, coming in the air. It's got to fully mix like a vapor and come up into the air. And the heavier stuff just doesn't get there. Doesn't get there. And the engines fail to be properly lubricated. So when people are looking for a two-stroke oil for those engines, it better say on the bottle that it meets like Evinrude E-Tech or Omni Max or whatever it happens to be, because if it doesn't, it's critical, because the oil will never make it through the air intake all the way to the cylinder